In this video, I will demonstrate various procedural texture techniques implemented in OpenGL and C++. The first will follow the technique proposed by Larson et al. In their approach to procedural knots, followed by various other techniques that implement some variations of noise. In this first example, we can see an animated texture being applied to a plank that has procedurally generated a texture with knots. I will demonstrate the volumetric rendering by adjusting the scale of the plank and how the method will generate the texture accordingly. You will notice more artifacts near the edges that occur as the scale of the model increases drastically. I will now demonstrate the procedural knots but on different sized models. You will notice the artifacts on the teapot example, as it is not able to effectively compute the texture value at relatively large ranges compared to the original Planck model. I will now demonstrate a purely random texture applied to the models. This is actually a pseudo-random function that accepts a vector 3 and returns the fractional part of a sine wave on that vector to compute the final color. This next texture will use interpolated noise in combination with the tune shader. The tune shading aspect considers 4 intervals for the color and quantizes them to the nearest interval. Adjusting the smoothness parameter of the shader modifies the frequency in which the noise will appear in the model. We can adjust this to get whatever effect we would like to see. Notice as the frequency of the noise increases, we are actually approaching the original random noise texture. The noise actually occurs on the volumetric data of the geometry, so we can see the noise accurately correlate with each other at the edges of the models. Since the interpolation is happening on the geometry where they exist in space, we can update the scale of the model and see that the texture is able to compute accurately and smoothly at all points of the model. We can adjust the root color of the interpolated noise to something more interesting.